Your notebooks are open so you can take notes. Today we're talking about Lesson 2.2, Module 2, Lesson 2. And your learning goal is to be able to estimate products by rounding the factors and using what you know about math facts. Let's remind ourselves, what is a product? When I say I'm going to estimate a product, what is a product? Vasisht?
The product is like the answer to a multiplication.
So the product is the answer to a multiplication problem. And I'm going to estimate the product by rounding the factors. What are factors, Ben?
Are they things in like multiplication problem?
Yeah, it's the two things that you multiply in order to get the product. Okay, so we're going to round the factors today in order to get an estimate of the product. What I hear you saying is if we're trying to figure out how many 5th grade students there are at Stockelmeyer, you guys don't need to write this down, we can think, okay, every class has about 30 students. Does every class have exactly 30 students? No, but we could say, every class has about 30 students, and there are actually 5 classes that have 30 students. Could I do this really quickly in my head?
Yeah.
How many is 30 times 5? I can think that this is 3 tens times 5. And so I could do 3 times 5 times the 10, right? So what's 3 times 5?
50.
And I have one factor of 10, so I will add 1 0. So there's about 150, but then I have to add, there's about 20 5th grade students in Mrs. Kim's class, so that's 170 students. Is that the exact number?
No.
Does every class have exactly 30 students?
No.
No, some have more, some have less. But on average, it's about 30 students in each class. So this is a quick way for us to think in our head. In fact, when I'm making copies for the entire 5th grade, this is exactly what I do. I make 170 copies because I know that most classes have about 30 students. Is that a lot faster than saying, okay, in room 47, there's 31 students. In room 48, there's 18. In room 49, there are 32 students. In room 50, there are 30. In room 51, there's 31. And in room 52, let's say there's 29. Is this way of thinking about it a lot faster than adding like that?
Yes.
So today, we're going to see how we can estimate, just like we did here. We estimated the factors, didn't we? So is our answer of 170 an exact number or is it an estimate?
Estimate.
But it was easy, right? And did it give us the information we needed? Yeah. So today we're going to see how we can estimate the products, get a rough answer to a multiplication question by rounding the factors, just like we did here. So when we're looking at this problem, we can think, well, 456 times 42. Can you do that in your head really quickly?
No.
No, right? So let's estimate. Let's round the factors. We can say 42 is pretty close to what number that's easy to think about? Sophia? 40, sure. Okay. And 456 is pretty close to what number that's pretty easy to think about? Arun?
500.
Sure. It could be pretty close to 500. Now, can we do this in our head?
Yeah.
Well, we can think about, can we use the commutative property to move things around? We can think of this as 500s times 4 what's?
40 tens.
Is it 40 tens or 4 tens?
4 tens.
Okay, then I'm going to use the associative property to group the 5 and the 4 together. And then I'm left with 100 times 10, right? So now I can do it. What's 4 times 5? I'm using my knowledge of math facts. What's 4 times 5? 20 times 100 times 10. So how many factors of 10 are there? I have 1, 2, 3, 4. So it's going to be 2 plus how many zeros? 1, 2, 3, 4. So I can estimate that the product of 456 times 42 is about how much? 20,000. Just like I could say 456 is pretty close to 500, I could say that 4,560 is pretty close to what number? 5,000, sure. Okay. And 42 is still pretty close to what number?
40.
40, right? Good. And then now I can see, okay, well, I can group my 5 times 4, which is still what? 20. And then how many factors of 10 do I have? 1, 2, 3, 4. So I could add 1, 2, 3, 4. Shift it 4 times. course, I'll add my commas. And now I can see that the product of 4,560 times 42 is pretty close to what number? 200,000. Okay. This time, we can say that 4,560 is pretty close to what number? 5,000 still. Good. But then for our second factor, 420, is it still close to 40? No. This time it's close to what? 400. So I still have the same basic math fact of 5 times 4, which is, I can group that together. But then this time I have times 1,000 times what? What else do I have here? 100, right? Because I have 4 hundredths. So I still know that 5 times 4 is 20. But then how many factors of 10 do I have this time to add? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then I'll add my commas. And I can say that 4,560 times 420 is pretty close to what number? 2 million. Now, are there any numbers we could estimate to? We could round the factors. Is there any way we could round the factors to get a more accurate answer or an answer closer to our actual answer? Instead of rounding 456 to 500, could I round it to 450 times 40? Then we would have to use distributive property to think of this as 400 plus 50, right? So it's a little bit harder, but can we do it? Yeah. Which answer would be closer? Which answer would be closer to the actual answer? Sporty?
450 plus 40.
Why? Why would this way of doing it, this way, be closer to the real answer than this way?
Because we estimated 450 and 40 closer than 500.
You got it. When we were rounding the factors, is 450 closer to the real number or is 500 closer to the real number?
450.
Yeah, 450 is closer to the real number. So which one's going to be closer to the real answer? This way, right? So both ways are okay. When we estimate, is there only one right way to do it? Unless it specifically says round to the hundreds place or rounds to the tens place, there's no one right way to do it. Does that make sense? Good.